Example 5, a camera at ground level is filming the liftoff of a rocket that is rising vertically according to the position function s equals 50 t squared, where s is measured in feet, t is measured in seconds. The camera is 2,000 feet from the launch pad. Find the rate of change in the angle of elevation of the camera at 10 seconds after liftoff. Alright, so we got a camera. Okay, camera is 2,000 feet from the launch pad. Here's my rocket. Okay, we got an angle here. This is s. S equals 50t squared. We know that we're finding d theta, the rate of change of the angle of elevation with respect to time, when t equals 10 seconds. Okay. So we also know that tangent of theta for this problem would be opposite over adjacent. Okay. And let's see, if we wanted to, we could write this as the inverse of tangent is s over 2,000 equals theta. And now if we take the derivative of this, we'll have, with respect to t, we'll have d theta dt. So let's do that. Let's take the derivative of this whole thing with respect to t. So we know that the derivative of arc tangent of u with respect to x is u prime all over 1 plus u squared, where for my particular problem, u is equal to s over 2,000, and u prime would be equal to 1 over 2,000. Derivative of s is 1. You got the constant of 1 over 2,000. So let's see here. I'm going to have 1 over 2,000, okay? And I'm taking the derivative of s with respect to t, so I got to multiply this by ds dt all over 1 plus u squared, so this would be s over 2,000 squared equals the derivative of theta with respect to time. Alright, so now we need the derivative of s with respect to t. So let's look at s equals 500 t squared. Let's take the derivative with respect to t. So this would be ds dt equals 100 t. Okay. We know for our particular problem that t is 10, so ds dt is going to be 1,000. So now I've got 1 over 2,000 all of times 1,000. 1 plus 10, or s, we got to figure out s. So I can use this s equals 500 t squared, where we know that t is 10. 10 squared is 100 times 50. That's going to be 5,000. So now I can do 5,000 over 2,000 squared. And this is equal to d theta dt. The numerator, you've got basically 1,000 over 2,000. I'm going to make that 1/2. 1 plus, let's make this 5 over 2 squared equals d theta dt. Let's square 5/2. That's going to be 25 over 4. And then let's make 1. Let's make this 4 over 4. So this would be 29 over 4. And then let's multiply the numerator and the denominator by 2, giving me 1 over, well, let's multiply it by 4, making this 2 over 29. So now I know d theta dt is 2 over 29 radians per second? Yes, seconds.